OK, so this is what's happened. So what we've done is we've looked at a particular kind of ordering of a set, which is a well ordering, of which the basic principle is this one. And the basic tool we're going to use to talk about big infinities is to think about types of well orderings. And what's cool about well orderings is that they can be organized very, very neatly. So I'm going to give you an exhaustive list of the well orderings. So I'm going to show you the shapes of all well orderings, or at least the first few, but you'll see the pattern. So the simplest well ordering of all is the trivial ordering of the empty set. So the empty set has nothing, so there's nothing to order, so you don't have to say nothing. Trivially, if you take a non-empty set, whatever you want is true, because there's going to be no non-empty subset of the empty set. OK, so here is the shape of the empty well ordering. There. OK, that's the simplest of all. Now, the next simplest is the well ordering of a set with a single element. So the shape of that well ordering is just that. There's only one element, and there's no need to compare her with anybody else. All there is her. And then if you have a set with two elements, every well ordering is going to have that shape. There's going to be one, and then there's going to be another. Of course, that doesn't mean that you can only well order a set in one way. It's just that any two well orderings are going to have the same shape. So for example, take the set 1, 2. That could be well ordered like that, and it could be well ordered like that. And of course, it can make a big difference. For example, if the ordering is, if these are like someone's children, and the well ordering is like who's the favorite, then that can make a huge difference. But both of these well orderings have the same shape. It's the shape first one and then the other. And if you take sets of 3 elements, then the only type of well ordering you're going to have is one, and then another, and then another, and so forth. So for sets with finitely many things, there's going to be exactly one kind of well ordering, and it's exactly what you would think it is. But things get interesting when we move to sets with infinitely many things. So the smallest infinity is the infinity of the natural numbers. And there are many ways of well ordering that set. There are many shapes that a well ordering of that set could take. So the simplest well ordering of that set is that one. But as we've seen, there is a well ordering of that set that has a different shape. Same number of elements. It's just that that's a different kind of well ordering for that set. And then this one, and then this one, and so forth. And now you can start to see what's so awesome about well orderings. The thing about well orderings is that any two well-ordered types are such that one is an initial segment of the other. I'm going to write that down because it's so cool. The reason that's so cool is because it means that we can order the well-ordered types. Because you can just say, if you have two well-ordered types, you can say that the smaller one is whichever one is an initial segment of the other. So you can say that, for example, you take these two, you can say that that one's smaller, because this one is an initial segment of that. And if you take this one and that one, you can say that this one's smaller because it's an initial segment of that one, and so forth. In fact, it's not just that the well-ordered types are ordered by the initial segment relation. They are well-ordered. So the well-orderings form a well-ordering. And that is our trick. Because the well-orderings are so well-behaved, what we can do is we can supply a theory of well-orderings. And we're going to develop bigger and bigger well-orderings. And each well-ordering is a blueprint for an enormous set